Welcome back. In this lesson, we're going to talk about loops, probably the most powerful concept in this course. Now, the thing about loops is that they allow us to repeat tasks extremely fast many times. But the bad thing is that when you first see the code for the first time, it can be a bit cryptic and weird. So what I want to do now is just step away from looking at any code whatsoever, all right? And I'm going to explain to you the concept behind loops and the code without showing you any code at all. So let's go. All right, so here I have a stack of pennies. And if I told you, hey, give me 4 pennies, you would probably just reach out, grab 4, and move them over here. Now the thing is, when we're talking to a computer, we have to give it very specific instructions, all right? It can't just visually right now recognize 4 pennies as quickly as we can. And even when you did this in your head, you probably, very quickly, before you even grabbed them, counted 1, 2, 3, 4, and then you put your fingers there, and you knew to grab them down here. Now, when we're talking to a computer, it's like talking to a child. We need to give it very specific instructions, all right? So even a child, if we asked it, give me 4 pennies, it's going to do it one by one. It's going to say, all right, I'm going to take 1, I'm going to take 2, I'm going to take 3, I'm going to take 4. And when it gets to 4, it's going to say, hey, you know what? 4 is all they asked for, so now I'm going to stop. And with a computer, it's very similar, okay? When we ask a computer to do something 4 times or 10,000 times, it needs to set up a counter in its head so that it can keep track of how many times it's done something. And before it does something, it needs to ask itself, hey, have I done this thing enough times? And when it's done doing that thing, it also needs to update its counter. So it's going to look something like this. If I ask the computer, give me 4 pennies, it's going to say, okay, right now I have 0 pennies, and 0 pennies is less than 4. That means I can take a penny and move it down here. And once I've done that, the computer's going to say, okay, I now have 1 penny. And then it's going to say, hey, is 1 penny less than 4 pennies? It'll say yes, and then say, okay, now I can take another penny and move it down here. And what I'm going to do is increase the number of pennies to 2. Then the computer says, hey, is 2 pennies less than 4? Yes, it is. It grabs another one and increases its counter till 3. Again, it says, hey, is 3 less than 4? Yes, it is. Let me grab another and bring it down here. And now my count is 4. And now the cool part is that the computer says, hey, is 4 less than 4? No, 4 is equal to 4. I now can stop. Here are your 4 pennies. So in order for the computer to have this fun little conversation with itself, we need to give it some information in the form of writing some code. So let's just go over the 4 components of a loop, all right? The first thing we need to do is set up a counter variable to keep track of how many times the loop has run. Each time the loop runs, we're going to refer to that as an iteration. It also needs a condition to check before each iteration of the loop. In my little example with the pennies, we were always checking to see whether or not the counter has reached the number 4. We also need some task to perform on each iteration. In my little example, a penny was being moved across the desk. In the project we're building, we're going to be pulling pencils out of the library and placing them on the stage. And lastly, something to do after each iteration, okay? In my example, every time we moved a penny, we increased the counter variable by 1, okay? So that's very typical when you're running a loop. Every time the code runs, you increase your count by 1. So next what we're going to do is investigate the code that we're going to write to give all this information to the computer. And I promise you, it won't be that scary.